again, we just wanted to call out the Cloud Skills Challenge. So if you go to aka.ms/ai/challenge, it's just at the bottom of the screen just here, and you'll be able to go and take a look. You can win a goodie bag of swag if you rank in our top 10 of our leaderboard, and we've got about 40 people so far signed up, which is great, and 3 have completed some of the modules. So do get in there, start looking at what's available. You do have a full week though to complete this, so no rush. Do continue to pay attention in some of our sessions. Okay, that's for some of our announcements. Up next, we are staying on the same topic, and we're going to be talking about teaching your models to play fair with Rishit. So Rishit, are you there? Could you turn on your camera for us? Fantastic. Hi, how are you doing?
Hi, I'm doing good.
Good stuff, good stuff. Rishit, can you introduce yourself very briefly?
Okay, sure. So I have a slide for it and I'll cover it now.
No problem. Let's hand it over to you then. I can see you're sharing your screen, so we'll get that up on the stream now for you. And yeah, feel free to take it away.
Thank you. Thank you for having me. And I'll start right away. Okay. So hi everyone. As Amy said, I'm Rishit, and I'll be talking about teaching your models to play fair. So how you can ensure fairness in your machine learning applications is what I'll be talking about today. And we'll also have some cool demos at the end, which you can try out for yourself too. So stay tuned till the very end. So I'll start first off, before I move any further, let me tell you that I'll try to take questions. So if you have any questions, feel free to put them in the chat. And I'll try to take questions if I have enough time at the end. If not, I'll try to answer them in the chat after the talk in the chat itself. So a bit about me. So I'm a high school student from India. I'm a TEDx and TEDx speaker, and I love to speak at conferences like these. Thanks for having me. I also love hackathons and competitions, and have represented my country in quite a few of them and even won them. I also love research and have published multiple research papers on AI and mathematics. Feel free to check them out if that's what you are interested in. And to know more about me or connect with me, here are my coordinates at rishit.tech. So feel free to go on this website and know more about me. So that's about me. Let's get to the talk now. So before I even start off with what we are going to do about today, I would like to point out who the ideal audience would be for this talk. It would essentially be AI developers who have worked on making any kind of models. So if you have made a TensorFlow model, if you have made a scikit-learn model or a PyTorch model earlier, this talk is for you. You'll be able to make sense. And it would also be AI developers who are looking for ways to build fairer and inclusive and more inclusive applications. So that is who the ideal audience would be for this talk. So just a bit about what we are up to today. We'll start off with the idea of responsible AI, and then we'll go on a bit about what is fairness. The speaker, the talk just before me covered a bit about fairness. So I'll tell you a couple of things from the modeling perspectives about what fairness means to you and why you should care about this. Because, well, I could have spent 30 minutes learning a new modeling strategy, but why should I be caring about fairness is also what I'll be telling you. Then we'll also take a look at FairLearn and finally go on to see some live demos. So let me start with the idea of responsible AI. So the development of AI is creating new opportunities to improve the lives of people all around the world, from business to healthcare to education. AI is revolutionizing almost every industry out there. I do not need to talk much about it. So at the same time, it is also raising new questions about best ways to build fairness, to build models which have fairness, which are interpretable, which take care of privacy and security into these systems. And there's a lot to it. For this talk, we'll be discussing about a part of responsible AI practices, or the four major principles of responsible AI practices, as I like to call it, which is fairness. So that is what we'll be discussing for this talk. So let's start with what is the idea behind fairness all about. So at this stage, I like to explain it. You might be aware of the meaning of the word fair and can make a pretty good guess about what it means in the machine learning context. So instead of telling you any definition kind of stuff, let's take an example and see it through. So what I want you to do is, in your mind, I want you all to think of a rose. I'll give you a moment to do that. So what did you think? I, and mostly most of you out there, would have most probably thought about a red colored rose, which is the most common one. I also thought about the red colored rose myself. But some of you might have also thought of a white colored rose. Again, this also classifies as a rose. And I guess no one might have thought of a blue or a blue shade rose. So I hope you are trying. I hope you are making some sense of the idea of fairness in the machine learning context. Let's take another example, a short one now. So I want you all to think of a pizza. So what did you think? Most of us thought about this, including me, a triangular slice of pizza. But well, this classifies as a pizza too, a rectangular shaped one. That classifies as a pizza too. So by now you might have got a fair enough idea of what I'm talking about. So with that, let me tell you a bit about what a fair algorithm is, or how you can say an algorithm is fair. So in these examples, you just saw that you are giving much importance to a particular kind of object based on maybe color, shape, or some other property, which is called bias. So what I want is, so on the slide right over here, it's written that property of a person does not affect the outcome. I want you to think of it with a minor edit over here, which is sensitive properties of a person should not affect the outcome. So if you have a voice recognition system which does not detect, let's say, women voices and only detects men voices, or is only able to correctly understand men voices, that's bad. And you probably have a bias in your model. So your AI model should also not favor, let's say, a particular race of people, or discriminate based on skin color and so on. Protected attributes or protected property is what I like to call them. So so as of now, I want you to understand a fair algorithm according to these 2 points which I've mentioned right over here. So it's a common misconception I've come across. I've come across this a lot, that since AI systems are based on mathematical algorithms and statistical models, it would be neutral or fair. And I hope you might have thought about this. You might have thought about this at a stage yourself, that, well, under the hood, AI is just maths, statistics, mathematical algorithms. So it would be neutral or fair. But you could essentially also have data which is biased due to the way it is collected, or maybe the model itself could introduce unfairness, or you could have the deployment process introduce some bias. So what's the motivation behind all of this? How important it is to actually talk about bias? So again, the analogy where you could have learned, you could have spent 30 minutes on learning some new kind of modeling technique, why you should be attending this talk and learning about fairness. I'm sure you all know about GPT-3. It's pretty trending topic now. All of you, I'm pretty sure you know about GPT-3, and it was trained on over 100 billion parameters, performs so well on multiple tasks, but still faces bias. It is so uh, in this tweet, a person mentions how the GPT-3 is biased for Muslims, and this is indeed a huge problem. Even after being trained on billions of parameters, performing so well on other problems, it still faces bias. And this is a huge problem. It is discriminating Muslims, as showed in this tweet. Or take translate, for example. It automatically classifies professions to gender-based pronouns. So she's a nurse, he's a scientist, whereas the original sentences were indeed gender neutral. So this is also an example of how important fairness is in production level applications, and people have also started to realize how important this is, especially in production applications. Just a cool little stat showing the number of research papers in a year about fairness in ML. A lot of work being done in this field. So in 2011, there were just 11 or so papers a year about fairness in machine learning. And going back to 2017, I actually took this stat. So going back to 2017, a lot of research papers about fairness in ML, people have started to realize how important ML is for production applications. So let's see how we can improve our models or allow them to play fair. So first off, worth a mention that fairness in AI is both a social and technical challenge. Data could be biased due to social problems. So we'll see on such a tool called FairLearn to help us introduce fairness in applications. And you'll also see how easy it is to do so with FairLearn. So also note, FairLearn is experimental, and a few things I say here, a few of the syntax I mentioned, the demos or which I say here, is uh, is vulnerable to change. So a part about FairLearn I love the most. Uh, so I'm talking a bit about FairLearn now and how you can start introducing fairness in your models. So part about FairLearn I love the most is the ease of assessing and mitigating biases with a dashboard. So so you could assess your model fairness from multiple features within a FairLearn dashboard. One way to start evaluating the fairness for a model, as shown in the slide right over here, is to compare predictions for each group with a sensitive feature. So here I have included age to be a sensitive feature, which is just an example. You could have something else too. Um, so we could split the data into subsets for each age group and compare the selection rate for each of these groups very easily with the FairLearn dashboards. So some groups may be overrepresented in the training data, or the data may be skewed so that cases within a specific group aren't aren't representative of the overall population which you have, leading to this bias. Or the sensitive feature itself may not be predictive of a label, and there are a lot of reasons, a million reasons due to which this could be happening. This or you could also compare various models very easily. So what I can also do with FairLearn is, well, I talked about how you can assess fairness of your models with FairLearn. So I also want to talk a bit about the mitigation dashboards. So I can very easily compare multiple models on uh, on some metric like accuracy and fairness and disparity very easily with FairLearn dashboards. You'll soon see how you can build these dashboards for your model and how you can improve your model. So let's talk a bit about this. As at the end of the day, what I want to do is uh, mitigate fairness into my model. So again, FairLearn helps you to do so. It's not just limited to assessing fairness in your models. So you have a couple of mitigation strategies with FairLearn that you can use again with the FairLearn dashboard. So as of now, FairLearn has these couple of mitigation strategies. And a common approach to mitigation is to use one of the algorithms and constraints to train multiple models and then compare the performance, selection rate, and disparity matrix uh, to find the optimal model for our needs. So I'll compare multiple models based on performance, a disparity, and selection rate metrics and find out the best model I need. So with FairLearn, you have a couple of mitigation, has a few algorithms for mitigating fairness in your applications. So for the scope of this talk, since I'm time bound, I'll not be going into details of how each and every algorithm here works, but you can know that these can very easily be used with FairLearn, as we'll be seeing in the demos. These models also support different fairness definitions. So as an example, the threshold optimizer right over here does not support error rate parity and so on. But yeah, I'll not go into detail about each of these algorithms right over here. So let's see an example of using the grid search algorithm, and let's see a sample example of it. Again, it's super easy to use mitigation strategies. And let's say I'm running a logistic regression algorithm and specified demographic parity, which is one of the most well-known, famous criterion for fairness. So what does the demographic parity mean? It essentially says that the difference between the groups getting the positive outcome should be zero. So if I have two or three groups, the difference between the group between all of these groups which get the positive outcome by the model should be zero. That's simply what the demographic parity means. And let's understand how easy it is to take a look at, make multiple models with FairLearn and check out the best model for yourself. So first off, I'm saying it is a logistic regression algorithm. So this could be anything. It could be a TensorFlow model too. But for simplicity, and for this talk, I've taken a simple logistic regression model from scikit-learn. I'll then specify demographic parity. As I said, it is one of the most well-known criterion, and which is and on that constraint we'll be measuring our fairness. And as the name suggests, we then do a grid search, make multiple models, see the stats and the trade-off between accuracy or any other metric with a fairness metric. So as of here, I have the disparity in predictions as a fairness metric, and I compare it with the model accuracy. So I can then take a pretty good look at the models which FairLearn has made for me, and and choose the right model. We take a look at how you can choose the right model, compare these models in the demos. But yeah, it's really good to know that you can very easily do this. And this was possible with just a few lines of code. So that is, again, I feel pretty cool. You'll soon see this in action too. Another great part is that FairLearn is integrated into Azure machine learning. So you can build these dashboards right in your Jupyter notebook with the results of your model. Or what you could also do is, now you have a fairness tab in Azure ML currently in preview. So for every run you do with Azure ML, you could see the fairness dashboards and how to mitigate them. The feature is also available within Azure ML once you register your trained model with it. So you can run an experiment in which the dashboard metrics are uploaded to your Azure machine learning workspace. What this allows you to do is then enables you to share the dashboard in Azure Machine Learning Studio so that your data science team can track and compare disparity metrics for models registered in the workspace. So makes the whole process a lot more easier, allows you to build shareable dashboards very easily. So that is also something I love with with FairLearn. So with that, I'll enough talking and let's get to the demos part. And this is the link for the demos. It essentially redirects you to a GitHub repository, and uh, this link is also present in the resources section. So you can take a look at the link from the resources section or quickly make a note of the link right now from the screen. So it's bit.ly/FairLearn minus demos. So with that, let me quickly switch to my demo screen. Okay, so hang on with me for a moment. I'm switching to my demo screen. And here it is. Okay. Okay, so I hope you can see my demo screen now. And this is a GitHub repository, which I talked about, has a couple of examples for you, allows you to understand more about fairness and these demos itself. So today we'll be taking a look at one of these demos. And just before the session itself, I have run this demo. So it would have been, I wanted to execute this live, but doing the grid search takes up a pretty long time. So I executed all of these just before the session, so we can take a look at the outputs right now. So I'm taking the census data which we have. Okay. I hope it is better visible now. Forgot to zoom in. So I'm simply loading the census data. I'll perform a couple of data transformations. So in this tutorial, what we'll be seeing is I want to see if a person has their income greater than 50,000 or less than 50,000. So and I want to and I want my protected feature or protected attribute to be 6. So that is what I'm doing over here, and just performing a couple of data transformations right over here. Nothing great over here too. Splitting the data into training and test sets. If you have worked with creating ML models, you most probably know how all of this works out with scikit-learn. And again, I'll be showing you code on how to do it with scikit-learn with a simple logistic regression algorithm. So you can very easily replicate this on your own machines too. But be aware that you can most certainly use a TensorFlow model in its place too. So first off, I want to load this predictor into a fairness dashboard and examine how unfair my model is. So this is a simple model. It has no idea about fairness, or as I like to call it, it's an unmitigated or original model. So I load it into the fairness dashboard, FairLearn dashboard. Since I'm at the dashboard part, I also wanted to tell you, as of now, FairLearn dashboards are only available in Jupyter notebooks. So I'm using a Jupyter notebook right over here. If you try to run this in Colab or Jupyter Lab or some other Jupyter-based environment, you wouldn't be able to run these FairLearn dashboards. So just a note, I wanted you to be aware about it. Okay, so let's go in, and the FairLearn dashboard tells me to set up my assessment. I need to complete 2 steps. So let's see what those 2 steps are. First off, it wants me to specify the sensitive features. As I said, I just want to I want to take the sensitive feature as 6. So let's just select that, click on next. And I now have a couple of metrics on which I can calculate the model. So as of now, just selecting simple accuracy, the fraction, which is the fraction of data points which are classified correctly. So I'll just select that for now, but this may very well vary with your business use case you are trying to solve. So As an example, for a medical use case, you would most probably want less number of false positives. So that all of that would vary with your business use case. So first off, I see disparity in performance or disparity in accuracy. And I see 83.8% is my model accuracy. Well, I did not want to train a model with very high accuracy. It's just a demo. So yeah, I have a model with 84% accuracy. I can see the accuracy for male class. The accuracy for male class is 79.5%. And I can see the accuracy for female class, which is 92%. I can also see the under prediction and over prediction rates for the male and the female class. And the difference between both of these accuracies of the male class and the female class, so 92.4 minus 29.4, which is 12.9, is the disparity in accuracy. So I also see disparity in predictions, which is essentially the selection rate. And I see that 23.1% of the males had their income above 50,000, and 7.5% of the females had their income above 50,000. So calculating the disparity in the selection rate, I have a 15.5% disparity in the selection rate. So this is not a very great a disparity which I have. So I'll try to improve it now. So this is essentially the part where it takes up a lot of time building multiple models. So this is where we are doing the simple grid search, which was also there in the slides. I'll make multiple models with it, and I'll go, and there's just some simple code right over here, allows me to format my data, and I'll go to the dashboard now. So again, I have two steps. Let's see what those two steps are. They're again same. The sensitive feature, let's select 6. We are doing on that. I'll select accuracy again. I already mentioned why I'll do that. And here I have it. FairLearn created all of these models for me with just a few lines of code. I don't need to do a lot of things. So my unmitigated model is over here. It is at almost 84% accuracy, but has a disparity in predictions of about 15%. So you can, according to your business use case, you can take a look at all of these models. I most probably might go with this model right over here. So let's click on it to know more about it. And I see that the overall accuracy of this model is 78.4%. I've lost a bit on the accuracy, but let's see the disparity in selections, and it's 0.5% disparity in selections. So I went from 15% to 0.5%, and I got a bit of lower accuracy, which may be acceptable to me. So I think, so this is what we just mitigated with FairLearn. And you can also see all of this right in Azure ML. So since I'm running out of time, I'll not show the grid search part in Azure ML itself. But yeah, you can also see multiple models that FairLearn creates for you in Azure ML too. So with that, let me quickly switch my screen.
Yeah, excellent. Thank you so much, Rashid, for a great presentation. I don't think time for questions. I just wanted to mention that FairLearn works pretty well with the models with features, right? So it's like tabular data or something like that. But the fairness problem also lies when we want to train, for example, on the images, right? And it's not that easy to detect disparities and imbalanced data sets when we have images and we want to solve, for example, image classification problems. So FairLearn is a really great tool, but it's only just the beginning to consider the problem of fairness in AI models.
Yeah, I feel that's true. There's a lot more to do. And one of the things which I also truly believe is this is not just a technical challenge which we can solve. it's a societal plus technical challenge. So we have to do work from both the aspects.
Exactly. And it's great that there is a lot of discussion nowadays around that. So thank you again. And I would like to welcome our next speaker, Nigama. So Nigama will tell us about how